Alright, so welcome back. Now, the second one here is a little bit more complicated than the last one. The last one we did in just only in one step. This one's going to take a little bit longer, so I'll run through it together with you. Now, as always, first step is you separate your left side and your right side into two different equations so we can work with them independently. A good rule of thumb when you're starting with any trig identity is to put everything and everything at all in terms of sine x and cosine x. So that means if you see a cosecant or a secant, turn it to 1 over sine x or 1 over cos x. If you see a tan or a cotan, turn it to sine over cos or cos over sine. Okay, if everything's just in terms of sine and cos, there's potentially some algebra that can be done to simplify it, and then at least both sides of the equation at least have the same terms and the same ratios in them, so we can start to make them look a little bit more equal to each other. So I'm going to do that here. So we know that tan x is equal to sine x over cos x, so tan squared x will be equal to sine squared x over cos squared x. Okay, so I have sine squared x over cos squared x minus sine squared x. Okay, and I'm going to do the exact same thing with the right-hand side over here. I'm going to replace every tan and cosecant with something in terms of sine and cosine. So again, tan squared is equal to sine squared x over cos squared x. Okay, and cosecant squared x is 1 over sine squared x. Now at first glance it looks like I made each of these sides of the equations uglier, but sometimes we have to make these equations uglier before they can be made nicer. Because again, now at least everything has sine and cos on each side, so we're not dealing with multiple different ratios, just sine and cos, so we can hopefully simplify them. Now, with both of them, there's different approaches to simplifying them. I'm going to work with the one on the right first, and what I see right now is a fraction within a fraction. So when I divide fractions, remember it means I'm multiplying by the reciprocal. So again, in slow motion here, you don't necessarily have to write out this step, but I will just to show you how it works. This line right here is the same thing as having sine squared x over cos squared x, okay, divided by 1 over sine squared x, because I'm dividing those two fractions. Okay, and we know that then means that if we're dividing two fractions, we're multiplying by the reciprocal. So this becomes sine squared x over cos squared x. That doesn't change. Okay, times sine squared x over 1. Okay, so when I do that, all that's left to do when you're multiplying fractions is multiply the numerators, multiply the denominators. The denominator is easy. I have cos squared x times 1, which is cos squared x. Okay, for the numerator, I have sine squared times sine squared. Well, remember I'm multiplying powers of the same base. I add the exponents. This gives me sine to the 4th power of x. So it's sine x all to the power 4. Okay, so this is about as simplified as I can take it for now. Okay, I might need to come back to this later, but for now let's take a look at the left-hand side now. So what I'm seeing now, I have sine squared over cos squared x minus sine squared x. One of the other things that got mentioned a lot here with my strategies is simplifying. So that means working with fractions appropriately, potentially expressing everything in terms of a single denominator. So with the one we have here, we have two things that are being subtracted. One of them is a fraction. Let's try and put them under a common denominator. Okay, so a common denominator between sine x squared x over cos squared x and sine squared x, well, the common denominator is going to be cos squared x. Okay, so right now this is, remember, sine squared x over 1. So in terms of getting the common denominator, sine squared x already has that denominator, so that's going to stay the same. So I'm going to have sine squared x up here. Okay, and I'm going to subtract sine squared x. But now, because my denominator over here from sine squared x has changed from 1 to cos squared, I need to multiply the sine squared by the cos squared as well. Okay, so what winds up happening now is when I simplify this, I now have sine squared x minus sine squared x times cos squared x over cos squared x. Okay, now again, let's compare my left side to my right side. At least my denominator is now the same. I have cos squared x in my denominator on both sides, but my numerators aren't the same at all. Okay, now one of the other things you should always be looking to do is look for opportunities to factor. Looking at my numerator, I have two terms here, both of which have a sine squared x. I'm going to factor the sine squared x out of both of these terms. So if I do that, I'm going to have sine squared x. Okay, what's left over is going to be, from here there's going to be 1 left. I'm going to have 1 minus cos squared x left over. That's all over cos squared x. Okay, maybe looking a little bit nicer now. Last thing we need to do here, we're really close, right? We have sine squared and cos squared and 1 minus cos squared. Here we need sine to the fourth. Well, one of our identities from way back over here tells us from the Pythagorean identity, because sine squared plus cos squared equals 1, 1 minus cos squared equals sine squared. So whenever I see 1 minus cos squared in an equation, I can replace it with, sine squared. Okay, so using that, I'm now going to have sine squared x. 1 minus cos squared is, again, sine squared x. And that's all over cos squared. Okay, so when I multiply the numerators together, I get sine to the fourth power of x over cos squared. And now that's equal to my right side. And I'm done. Okay, so there's a lot of different stuff that had to go on here. And again, trig identities are like puzzles, right? You know what you have to wind up with in the end is the two sides being equal to each other. There might be multiple ways of getting there, but you need to find a way to get there. So it might involve making substitutions, it might involve factoring, finding common denominators, whatever you can do to simplify it. And it just takes a lot of practice doing as many as you can to sort of see all the different ways you can simplify a trig identity. So eventually there's lots of different things you've seen. There's very little that's new that's out there. Okay, so that's how this one works. Let's try another one down here. Okay, so you have sine x over 1 plus cos x equals to 1 over sine x minus cotan x. Okay, and as always, I'm just going to start off by splitting up my left and right hand sides. Okay, and again, as a rule of thumb, express everything in terms of sine x and cos x. So actually I'm going to do that right off the bat here. I see a cotan x. I'm going to replace that with cos x over sine x. Okay, because remember, tan x is sine over cos tan x is sine x over cos x, so cotan x will be the reciprocal cos x over sine x. Okay. So to simplify the right side a bit, at the very least I can see I'm subtracting two fractions. So look for common denominator. Well, they both have the same denominator already, so the denominator is sine x. Okay, so this is going to be 1 minus cos x over sine x. Okay, it doesn't quite look like the left side, but at least they're both under one fraction right now. Okay, so at this point you might be thinking, okay, what can I do now to try and get these to look close to each other? They look sort of similar, but they're obviously not the same. So one thing you can do, if you're looking at this, you'll notice that I need a sine x in the denominator, and I don't have it here. Now, right now there's nothing you can do with this, because it's 1 plus cos x. If it was cos squared, you could replace it with 1 minus sine squared, but that's not the case here. Okay, so what I'm looking for here, I need to have, if I want this left side and right side to be the same, I need to have a sine x in the denominator right here. Okay, I only have 1 plus cos x, I need a sine x. So I'm going to multiply so I can get a sine x in there. Okay, so I'm going to say, okay, I want a sine x in the denominator, I'm going to put it in there. The only problem is I can't just do that out of nowhere, right? One thing I can do, though, I can put a sine x in the denominator if I put a sine x in the numerator as well. Okay, and the reason I can do this is because really I'm not actually changing the equation, right? I'm multiplying by sine x over sine x, which is really just multiplying by something divided by itself, which is multiplying by 1. Okay, so I haven't actually done anything illegal here. So just to recap here, the reason I did this, I wanted a sine x in the denominator so it could look like the one on the right side. So I decided to multiply by something that would put 1 in there, but I can only do that if I put a sine x in the numerator as well. Okay, so what happens if I do this? So it means now my denominator becomes slightly uglier, because now I have my 1 plus cos x, okay, and my sine x. Okay, my numerator becomes sine squared x. Okay, so again, looks a little bit uglier right now, but hopefully I can do something with this now, because now the fact that I have a sine squared in the denominator, well, from my Pythagorean identity, sine squared is equal to 1 minus cos squared. Okay, so I have 1 minus cos squared. My denominator is still the same. I have 1 plus cos x times sine x. And maybe this is now starting to look a little bit more like the right side, except this is 1 minus cos squared x, and I have 1 minus cos x over here. But, again, we're still trying to simplify this further. 1 minus cos squared x actually factors. Okay, this is a difference of squares. So if you think back to your factoring from grade 10, if you had, for example, 1 minus a squared, this would factor into 1 minus a, 1 plus a. Okay, two perfect squares subtracted factor into this kind of pattern. Same idea here. 1 minus cos squared x is going to factor into 1 minus cos x, and then 1 plus cos x. Okay, so that's what my numerator factors into. And I still have my 1 plus cos x times sine x down here. Okay, so now, hopefully you can see now some things are going to start to cancel. Because now I have a 1 plus cos x in both the numerator and the denominator. Those can now cancel, and I'm left with 1 minus cos x over sine x. Okay, so now this is equal to the right side, and I'm done. Okay, so again, this was a little bit of trickery, right? But I was in a situation where I needed to have, there was nothing I could do to simplify, so I had to throw something into the equation that would help me get it to look like the right side of the equation. So I threw a sine x in the denominator. To compensate for that, I had to throw a sine x in the numerator, so I wasn't doing anything illegal. Then I did a substitution. I could do something with sine squared. It became 1 minus cos squared. You always want to look for opportunities to factor if you can. This is a difference of squares, so keep in mind that if you run into a situation like this, you can factor this into 1 minus cos x, 1 plus cos x, and that caused something to cancel. So part of it's looking ahead and seeing what needs to go away from the equation, so you can see what you need to get to factor something out. And again, it is very tricky. There's no one saying that this is easy. It does take a lot of practice, and again, you just want to see as many different methods of solution as you possibly can, and knowing when to use them is really what comes out of you doing more practice. Okay, so we'll do a couple more examples, and you'll get an opportunity to practice as much as you can on your own. So here's another one. Cotan x minus tan x over sin x cos x equals cosecant squared minus secant squared x. I'm going to let you try this one on your own just to see how far you can get. Sometimes the trig identities, the best thing to do is just sort of struggle with them as much as you can to try and see what works and what doesn't. So give this a try for a few minutes on your own first, and we'll run through it together when you're ready. Okay? So we'll see you in a few seconds. Okay, so let me show you my approach to getting the solution. There's often more than one way to get to a trig identity, but this is the way that I think is probably the most efficient. So first thing you're going to do, that I did anyways, I changed everything in terms of sin x and cos x. To my right side, I turned cosecant squared into 1 over sine squared, secant squared into 1 over cos squared. And then I did the same thing on the left side. So cotan x became cos over sine, tan became sine over cos. Okay, now on the left side, I have fractions and a fraction, but first I had to find a common denominator between the ones in the top and subtract them. So common denominator between sin x and cos x was sin x cos x. So that gave me cos x times cos x minus sin x times sin x for my numerator there, which simplified into cos squared minus sine squared. When I have cos squared minus sine squared over sin x cos x, all divided by sin x cos x, what happens here is that since you're dividing by sin x cos x and dividing again, this shifts down here, becomes part of that denominator down there. So you wind up with sin x cos x times sin x cos x, which is really just sine squared x cos squared x. Okay, so that's how the left side simplified. On the right side, with the 1 over sine squared minus 1 over cos squared, I again found a common denominator. This time the denominator was sine squared cos squared. So the 1 here got multiplied by cos squared x, this one got multiplied by sine squared x, and you end up with, again, cos squared minus sine squared over sine squared cos squared. So the two sides are equal to each other, and again, this identity was proven. Okay, so again, another tricky one, but lots going on with fractions and fractions, but again, the more you practice you do, the more you'll get used to dealing with those kinds of situations. So one more example to work through, and we'll do this in part 3.